Quantum jumping, exploring the interdisciplinary frontiers of physics, psychology, and neurology. The concept of quantum jumping explores the intriguing idea of parallel universes, where multiple versions of oneself exist across different realities. It suggests that by harnessing the power of focused intention, individuals can essentially jump to a desired reality, thereby potentially unlocking their full potential. This process involves shifting consciousness to align with the reality one wishes to experience, which holds the potential for personal growth and transformation. Whether one approaches this concept from a skeptical or believing standpoint, quantum jumping introduces the possibility of tapping into different versions of oneself to explore new skills, perspectives, and personal development opportunities. Discover the fascinating world of quantum jumping, where real science and metaphysics collide. Dive into the concept of infinite versions of yourself existing in alternate realities, and learn how focusing your intentions can help you shift consciousness to unlock your true potential. Whether you are a skeptic or a believer, this video will open your mind to the possibilities of experiencing different realities. Quantum jumping invites you to explore the mind-bending concept of parallel universes, where countless versions of yourself exist across different realities, suggesting that by harnessing the power of focused intention, you can jump to a desired reality, essentially shifting your consciousness to unlock your full potential, regardless of whether you consider yourself a skeptic or a believer in the concept of alternate realities. The concept of quantum jumping suggests that by harnessing the power of focused intention, individuals can potentially jump to a desired reality, essentially unlocking their full potential by shifting consciousness. This process involves aligning one's intentions with a desired parallel universe where the potential already exists, thus enabling personal growth and transformation. Whether one approaches this concept from a skeptical or believing standpoint, quantum jumping introduces the possibility of tapping into different versions of oneself to explore new skills, perspectives, and personal development opportunities. While the scientific basis of this theory is a topic of debate, it presents an interesting approach to self-realization and personal empowerment. In metaphysics, the concept of quantum jumping can be approached from various perspectives, each offering unique interpretations and implications. Here are some metaphysical concepts related to quantum jumping. Multiverse theory. Within metaphysical discussions, quantum jumping is often linked to the idea of the multiverse, which posits the existence of multiple parallel universes encompassing different quantum possibilities. Each quantum jump could be seen as an individual's path through the multiverse, navigating through a vast array of potential realities, with each quantum transition representing a divergence into a different version of existence. Consciousness and reality shifting. Metaphysical explorations of quantum jumping often delve into the role of consciousness in shaping reality. Some perspectives propose that individuals can consciously influence quantum outcomes, effectively jumping to different experiential trajectories through intentional focus, visualization, or intention setting. From this angle, the concept of quantum jumping is intertwined with the idea of conscious reality shifting and manifestation. Universal oneness and interconnectedness. Metaphysical interpretations of quantum jumping often engage with the concept of universal interconnectedness. Rather than viewing quantum jumps as isolated events, these perspectives suggest that all aspects of existence are interconnected at a fundamental level, and quantum jumping represents a reflection of this interconnected nature. The concept of entanglement in quantum theory is often extended to encompass a broader metaphysical idea of universal oneness. Non-local consciousness and timelessness. Some metaphysical interpretations of quantum jumping involve concepts of non-local consciousness and the timeless nature of reality. From this perspective, quantum jumping might be viewed as a reflection of consciousness transcending the constraints of localized space and linear time, allowing for experiences that defy traditional temporal and spatial boundaries. Potentiality and manifestation. Within metaphysical discussions, quantum jumping is often linked to ideas of potentiality and manifestation. Quantum transitions could be seen as shifts between different potentialities, where the focus of consciousness or intention plays a role in shaping which potentiality becomes actualized. This view intertwines the concept of quantum jumping with metaphysical notions of intentionality, willpower, and the nature of reality. These metaphysical concepts reflect diverse interpretations of quantum jumping, integrating ideas from multiverse theory, consciousness, interconnectedness, and the nature of reality. They contribute to ongoing philosophical and metaphysical inquiries into the implications of quantum principles on the nature of existence, consciousness, and the interconnectedness of all things. Metaphysics and psychology continue to intersect and influence each other in various ways in contemporary discourse. Here are some key aspects of the relationship between metaphysics and psychology today. Consciousness studies. The exploration of consciousness is a significant area where metaphysics and psychology converge. Metaphysical inquiries into the nature of consciousness and its relationship to reality intersect with psychological investigations of subjective experience, awareness, and the mechanisms underlying consciousness. This interdisciplinary approach sheds light on the complex nature of consciousness from both philosophical and scientific perspectives. Mind-body connection. The mind-body problem, which concerns the relationship between mental processes and physical phenomena, has long been a focal point for both metaphysical and psychological inquiry. Contemporary discussions explore how metaphysical principles, such as dualism, monism, or emergentism, interact with psychological research on the mind-body connection, mental health, and holistic approaches to well-being. Transpersonal psychology. Transpersonal psychology explores spiritual and transcendent aspects of human experience, often drawing upon metaphysical concepts and frameworks. This approach delves into topics such as expanded states of consciousness, spiritual awakening, and the interconnectedness of individuals with the larger cosmos, incorporating metaphysical ideas into psychological theories of self-actualization and personal growth. Quantum psychology. The integration of quantum principles into psychological theories, known as quantum psychology, reflects a convergence of metaphysical and psychological perspectives. Quantum psychology explores how quantum concepts like superposition, entanglement, and non-locality may inform understandings of human behavior, cognition, and consciousness, bridging metaphysical speculations with psychological research methodologies. Existential psychology. Existential psychology, influenced by existential philosophy, delves into fundamental questions about the nature of existence, meaning, and freedom. The intersection of metaphysical inquiries into existential themes with psychological explorations of human experience, authenticity, and personal responsibility offers a rich terrain for understanding psychological well-being and the human condition. Holistic approaches to health and well-being. The integration of metaphysical concepts such as energy systems, interconnectedness, and the mind-body-spirit connection informs holistic approaches to health and well-being in psychology. Contemporary practices like mindfulness, meditation, and energy healing often draw upon metaphysical principles to address psychological issues and promote holistic wellness. Consciousness expansion and personal growth. Metaphysical perspectives on consciousness expansion, personal growth, and self-realization inform psychological theories of human potential and optimal functioning. Contemporary psychology embraces concepts of self-transcendence, peak experiences, and the integration of spiritual insights into therapeutic approaches, reflecting the ongoing dialogue between metaphysical and psychological frameworks. The relationship between metaphysics and psychology today is characterized by a rich interplay of concepts, theories, and practices that bridge philosophical speculations with scientific inquiries into human cognition, behavior, and well-being. This interdisciplinary engagement enriches both fields, offering nuanced perspectives on the nature of reality, consciousness, and human experience. Aligning intentions with parallel universes, as suggested by the concept of quantum jumping, involves the process of focused intention, visualization, and mindfulness. This practice encourages individuals to focus their thoughts and emotions on a specific desired reality, essentially aligning their consciousness with the potential outcome they wish to experience. While this concept is not scientifically proven, it is often associated with introspective practices, such as meditation and visualization, to create a mental representation of the desired reality. As for scientific validation, the concept of quantum jumping and its relation to parallel universes is not currently supported by mainstream scientific evidence. While this notion can be intriguing, it remains a topic of debate and speculation within the realm of quantum physics and consciousness studies. Regarding documented success stories of quantum jumping, anecdotal accounts from individuals who have engaged in this practice often emphasize personal transformations, gaining new perspectives, and unlocking creative potential. Typically, these stories involve discernible shifts in mindset and behavior that align with the individual's desired reality. Harnessing focused intention often involves mindfulness practices, such as meditation and visualization. These techniques are commonly used to quiet the mind, cultivate positive emotions, and direct one's thoughts towards specific aims. Visualization plays an essential role, allowing individuals to create mental images of their desired reality and embody the emotions associated with it. The process for shifting consciousness, as proposed by the concept of quantum jumping, often involves entering a meditative state, practicing focused intention, and visualizing the desired reality. Meditation techniques can help individuals quiet their minds, enabling them to focus on their intentions and raise their self-awareness, thereby facilitating a potential shift in consciousness. It is important to note that while the ideas surrounding quantum jumping offer intriguing possibilities for personal development, they remain largely conceptual and have yet to be substantiated by empirical evidence or scientific consensus. Scientific evidence supporting the concept of quantum jumping, particularly in the context of parallel universes and shifting consciousness, remains limited and largely theoretical. While some aspects of quantum mechanics suggest the existence of multiple realities, the direct scientific validation of quantum jumping as a method to access parallel universes is not currently substantiated by empirical research or widely accepted within the scientific community. When it comes to harnessing focused intention, several techniques can be effective in helping individuals direct their thoughts towards specific goals or desired outcomes. Visualization, creating vivid mental images of the desired reality, and engaging all senses to immerse oneself in the experience, can strengthen the alignment with intentions. Affirmations, using positive statements in the present tense to reinforce beliefs and intentions, can help reprogram the subconscious mind towards desired outcomes. Meditation. Practicing mindfulness meditation can aid in calming the mind, increasing focus, and promoting a sense of clarity and alignment with intentions. Energy work, techniques such as yoga, tai chi, or sound healing can help balance the body's energy centers and create an optimal environment for focused intention. While successful consciousness shifting experiences are often subjective and personal, individuals may report instances where they felt a profound shift in their awareness, mindset, or behaviors after engaging in practices like meditation, visualization, or affirmations. These shifts can lead to increased clarity, enhanced creativity, improved emotional well-being, and a greater sense of alignment with personal goals and aspirations. However, such experiences are often individualized and may not have objective scientific evidence to support them. Success in consciousness shifting is often measured subjectively by the individual's own sense of personal growth and transformation. Empirical support for the success of consciousness shifting, particularly in the context of quantum jumping into parallel universes, is not currently established through scientific research. The concept of quantum jumping and its association with parallel universes is largely theoretical and speculative, lacking empirical validation within mainstream scientific studies. The scientific proof of quantum jumping into parallel universes remains an open question, as it falls outside the scope of traditional scientific methods and the current understanding of quantum mechanics. While quantum physics presents intriguing possibilities, the direct scientific validation of quantum jumping as a method to access parallel universes has not been substantiated by empirical evidence or robust scientific testing. The notions of consciousness shifting, quantum jumping, and parallel universes remain largely speculative and have yet to be scientifically proven or widely accepted within the scientific community. While these concepts may inspire thought-provoking discussions, they continue to exist in the realm of theoretical exploration rather than established scientific principles. In the context of quantum mechanics, quantum jumping is often tied to the notion of sudden, unpredictable changes in the energy states of quantum particles. Mathematically, these transitions are described using operators, wave functions, and equations that account for the probabilistic nature of quantum jumps. The representation of quantum jumps within these mathematical frameworks aligns with the fundamental principles of quantum mechanics, including quantum superposition, entanglement, and coherence. The mathematical representation of quantum jumps involves describing how quantum states change abruptly and unpredictably as particles transition between discrete energy levels. This mathematical description often involves treating the quantum particles as wave functions that evolve in time according to certain equations, such as the time-dependent Schrödinger equation. Special mathematical operators, such as the Hamiltonian, are used to represent the total energy of the quantum system and how it changes over time, thus accounting for quantum jumps and transitions between energy states. Quantum superposition. Quantum superposition refers to the ability of particles to exist in multiple states simultaneously until measured, reflecting the probabilistic nature of quantum particles in different energy states. This principle forms the foundation for understanding the concept of quantum jumping, as particles can exist in a superposition of energy levels before abruptly transitioning to a specific state. Entanglement. Quantum entanglement describes the quantum correlation between particles, where the state of one particle depends on the state of another, regardless of distance. While not directly related to quantum jumping, entanglement underscores the interconnectedness of quantum particles and contributes to understanding the non-local and probabilistic nature of quantum phenomena. Coherence. In quantum mechanics, coherence refers to the phase relationship between states of a quantum system, highlighting the stability and ordered behavior of quantum phenomena. Quantum jumping theories interact with coherence, which reflects the predictability and stability of quantum states, thus influencing the prospects of testing such theories experimentally. This notion plays a crucial role in understanding how quantum particles can transition or jump between different energy levels given the probabilistic nature of their states. Wave function evolution. The mathematical description of quantum jumps often involves the evolution of wave functions over time, driven by deterministic and probabilistic processes. Understanding the time evolution of wave functions is pivotal for capturing and predicting quantum jumps and transitions between energy eigenstates. These fundamental concepts provide the theoretical and mathematical basis for understanding quantum jumps and transitions within the framework of quantum mechanics. They contribute to grasping the complex and probabilistic nature of quantum phenomena, serving as foundational principles that underlie the mathematical representation of quantum jumping. Testing quantum jumping theories experimentally presents challenges due to their speculative and theoretical nature. Experimentation in this context may aim to explore how particles transition between energy states and the predictability of these changes. Quantum mechanics and related fields continuously strive to explore and validate fundamental quantum phenomena, but the direct experimental testing of quantum jumping in association with consciousness or reality shifts remains a conceptual and speculative area of study within the broader realm of theoretical quantum physics. The concept of quantum jumping is based on the fundamental principles of quantum mechanics, which is a foundational theory in physics governing the behavior of matter and energy at the atomic and subatomic levels. Quantum mechanics is rooted in several key principles and experimental observations that ultimately give rise to the concept of quantum jumping. These foundational aspects include quantization of energy. One of the central tenets of quantum mechanics is the quantization of energy, meaning that the energy of a system can only take on discrete, specific values. This is in contrast to classical physics, where energy is considered continuous. In quantum mechanics, particles can only occupy certain energy levels, and quantum jumping describes the transition of particles between these discrete energy states. Wave-particle duality. Quantum mechanics introduced the idea that particles, such as electrons and photons, exhibit both wave-like and particle-like behavior. This duality is expressed through the concept of wave functions, which describe the probabilistic distribution of a particle's position or energy. Quantum jumping involves the abrupt changes in the probability distributions of these wave functions as particles transition between energy levels. Probabilistic nature of measurements. Quantum mechanics ushered in the concept that the outcomes of measurements on quantum systems are inherently probabilistic. When measuring certain properties of a quantum system, such as the position or energy of a particle, the result is not deterministic and is instead described by probabilities. Quantum jumping describes the sudden, unpredictable changes in the probabilities of finding a particle in different energy levels. The concept of quantum jumping emerged from the need to explain and understand the behavior of particles at the quantum level, as described by the mathematical formalisms and experimental results of quantum mechanics. It is a consequence of the discrete nature of energy levels and the probabilistic behavior of particles, as described within the framework of quantum mechanics. The intertwining of quantum mechanics with psychology and neurology represents a fascinating and evolving area of interdisciplinary research that seeks to explore the potential connections between quantum principles and phenomena observed in the fields of psychology and neurology. The integration of quantum mechanics with psychology and neurology can lead to fresh insights and alternative perspectives on human behavior, consciousness, cognition, and brain function. Here is how these fields intersect. Understanding human consciousness. Quantum theories are sometimes used to explore the nature of consciousness and subjective experiences in psychology. By considering the quantum principles of superposition and entanglement, researchers aim to shed light on how consciousness emerges and how it may be connected to the physical processes in the brain. Emotional states and cognitive processes. Quantum concepts are applied to study emotional states and cognitive processes in psychology. The idea of quantum superposition, where emotional states can exist in multiple states simultaneously, contributes to understanding the complexities of human emotions and thought patterns. Neuroplasticity and brain dynamics. Quantum principles may be used to investigate neuroplasticity and brain dynamics in neurology. The application of quantum physics to the study of how the brain changes and adapts over time can provide new insights into learning, memory, and neurological disorders. Brain-mind connection. By exploring the quantum aspects of brain function and the mind-body relationship, researchers aim to bridge gaps between physical processes in the brain and subjective experiences. This approach suggests that mental states may influence neural activity in ways that extend beyond traditional explanations. Exploring conscious choices. Quantum theories challenge traditional views by suggesting that human agency and conscious choices play a fundamental role in shaping reality. This perspective offers a new framework to investigate the relationship between human behavior and quantum phenomena. The intersection of quantum mechanics with psychology and neurology offers a novel lens through which to examine human behavior, cognition, and consciousness. While still a growing and speculative field, this interdisciplinary approach holds promise for enriching our understanding of the complexities of the human mind and brain from both quantum and psychological perspectives. Some specific examples of the integration of quantum mechanics with psychology and neurology include quantum cognition. Quantum cognition is an emerging field that applies principles of quantum mechanics to cognitive science and psychology. Researchers in this field explore how decision-making, judgment, and reasoning can be understood using quantum probability theory. The application of quantum principles to human cognition suggests that mental processes may exhibit quantum-like properties, challenging traditional models of rationality and decision-making. Quantum neurobiology. Quantum neurobiology delves into the potential quantum nature of biological processes associated with the brain. This interdisciplinary approach seeks to uncover how quantum phenomena at the cellular and molecular levels may influence brain function and neuronal processes. Proponents of this field suggest that quantum phenomena, such as quantum coherence and entanglement, may play a role in information processing and communication within the brain. Psychological models of quantum phenomena. Some researchers use quantum-inspired models to explain psychological phenomena, such as memory, perception, and consciousness. These models draw parallels between quantum principles like superposition and uncertainty with elements of human perception, memory formation, and the integration of sensory information. Mind-body interaction. The exploration of how mental states, emotions, and conscious experiences relate to neurobiological processes involves the application of quantum concepts. Researchers investigate the potential impact of mental and emotional states on brain activity, considering the possibility of a more integrated view of the mind-body relationship. Quantum-inspired approaches to brain function. Quantum-inspired approaches have been proposed to understand brain functions such as learning, memory, and adaptive processes. These approaches aim to address the inherent complexity and nonlinearity of brain function by drawing from the mathematical formalism and conceptual framework of quantum mechanics. Potential therapeutic applications. While speculative, The integration of quantum principles with psychology may lead to innovative therapeutic approaches, such as quantum-inspired psychotherapy or mindfulness interventions. These approaches may leverage quantum concepts to encourage changes in perception, enhance cognitive flexibility, and support emotional well-being. These are a few examples of how quantum mechanics, psychology, and neurology intersect. While the practical applications and implications of these integrations are areas of ongoing investigation and debate, they demonstrate the burgeoning interest in bridging these distinct disciplines to explore the complexities of the human mind and behavior from both quantum and psychological perspectives. The intertwining of psychology and neurology with quantum jumping involves exploring potential connections between quantum principles and phenomena observed in the fields of psychology and neuroscience. While this area is still speculative and subject to ongoing research, several key aspects illustrate how psychology and neurology intertwine with the concept of quantum jumping. Quantum influence on thought and perception. Some researchers explore the idea that quantum principles might influence human thought processes, perception, and consciousness. This view suggests that certain aspects of cognition and mental phenomena might exhibit features reminiscent of quantum behavior, such as superposition or entanglement. Investigating whether quantum phenomena play a role in shaping cognitive processes and subjective experiences forms an area of inquiry within this intersection. Ongoing research delves into quantum cognition, exploring the application of quantum probability theory to decision-making, judgment, and perception. Researchers seek to understand whether human cognitive processes can be better explained and modeled using quantum principles, challenging traditional classical models in cognitive science and psychology. Consciousness and quantum processes. The investigation of potential quantum aspects of consciousness intersects psychology and neurology with quantum jumping. This area delves into whether the concept of quantum superposition or other quantum phenomena might underpin conscious experiences, adaptive behaviors, or neural processes. Researchers explore the possibility that conscious states could be entangled with certain brain processes, thus influencing cognitive function and awareness. Studies aim to elucidate potential connections between consciousness and quantum phenomena. Ongoing research explores whether aspects of conscious experiences or mental states could exhibit quantum-like characteristics, influencing perception, awareness, and cognitive function. Neurophysiological extensions. Quantum jumping is considered within the context of neurophysiology, seeking to understand if specific neural processes or phenomena might exhibit characteristics akin to quantum behavior. This facet aims to explore whether certain aspects of brain function, such as learning, memory, or cognitive processes, might be influenced by quantum phenomena at the cellular or molecular level. Research investigates potential neurological correlates of quantum-inspired models of cognition and decision-making, aiming to identify neural processes that might align with quantum principles or offer insights into how the brain reflects features reminiscent of quantum behavior. Mental states and quantum phenomena. Researchers explore how mental states, emotions, and subjective experiences could be related to potential quantum-like phenomena in the brain. This intersection involves examining whether mental and emotional processes might reflect features reminiscent of quantum processes, thus shaping brain dynamics, perception, or cognitive functioning. Ongoing studies involve behavioral and cognitive analyses to assess how quantum-inspired models might impact understandings of human behavior. This area of research explores whether quantum models of cognition and decision-making offer new insights into understanding and predicting human behavior in psychology and neuroscience. Research explores the interplay between emotional states, consciousness, and potential quantum phenomena. Ongoing investigations seek to elucidate whether emotional experiences might correlate with features that have analogs in quantum behavior, shedding light on how emotional states could influence cognitive processes. Neurobiological applications of quantum principles. Ongoing research delves into potential neurobiological applications of quantum principles, with studies examining whether quantum phenomena might have implications for neurological processes, memory formation, or adaptive behavior. The intertwining of psychology and neurology with quantum jumping remains speculative, with ongoing exploration focusing on determining whether and how quantum phenomena might be relevant to numerous aspects of cognitive functioning, brain processes, and conscious experiences. As research in this area advances, ongoing interdisciplinary endeavors aim to elucidate potential links between quantum principles and various facets of psychology and neurology. Ongoing research explores the potential links and applications of quantum principles to cognitive processes, behavioral analyses, and neurological phenomena. While this area of research is still evolving and speculative, continued interdisciplinary investigations aim to uncover new insights into the complexities of human cognition and behavior through the lens of quantum-inspired models. Quantum principles have the potential to offer new and alternative perspectives on behavior, cognition, and decision-making. While this approach is still in its formative stages and remains speculative, the application of quantum principles to human behavior represents an interdisciplinary endeavor that seeks to expand traditional understandings of human cognition and decision-making processes. Here are several ways in which quantum principles could offer new perspectives on behavior. Non-deterministic decision-making. Quantum principles challenge the traditional deterministic view of decision-making by introducing the notion of superposition, where entities exist in multiple states simultaneously. This concept can offer a fresh perspective on understanding how human decision-making processes might exhibit non-deterministic aspects, potentially influencing choices and behavioral outcomes. Uncertainty and probability. Quantum principles, such as the Heisenberg uncertainty principle, underscore the inherent uncertainty and probabilistic nature of quantum systems. Applying these principles to behavior and decision-making offers insights into how individuals grapple with uncertainty, risk perception, and probabilistic reasoning in various contexts, including economic choices, risk-taking behavior, and interpersonal decision-making. Entanglement in social dynamics. The concept of entanglement in quantum theory, where particles become interconnected and influence each other's properties, offers a novel lens through which to view social dynamics and interpersonal relationships. By considering the potential entanglement of individuals' thoughts, emotions, and behaviors, quantum-inspired perspectives may shed light on the interconnectedness of social interactions and the influence of shared experiences on behavior. Complex adaptive systems. Quantum principles can provide a framework for understanding complex adaptive systems, including the dynamics of human behavior within social, economic, and organizational contexts. By drawing parallels between quantum complexity and the intricacies of behavioral systems, researchers can explore how behavior emerges from the interactions of multiple agents, analogous to quantum systems evolving through entanglement and emergent properties. Non-local effects on behavior. Quantum principles challenge classical notions of locality, suggesting the potential for non-local effects to influence behavior and cognitive processes. Exploring how non-locality might relate to interconnected mental states, social behaviors, and cognitive phenomena can offer new perspectives on the interplay between individual and collective experiences in shaping behavior. Overall, While the application of quantum principles to behavior is a nascent and speculative area, it holds promise for offering fresh perspectives on human decision-making, social dynamics, and the complexities of behavioral systems. As interdisciplinary research at the crossroads of quantum principles and behavioral sciences continues to evolve, it may yield new insights and alternative models for understanding the intricacies of human behavior from a quantum-inspired perspective. Quantum jumping involves navigating the probabilistic nature of quantum systems, where different outcomes coexist as potentialities. This notion prompts exploration of the role of uncertainty, probability, and the observer effect in shaping individual experiences and decision-making processes. Quantum jumping invites speculation about the nature of reality, the multiverse, and the interconnectedness of existence. This concept raises questions about the role of consciousness in shaping individual experiences, leading to metaphysical inquiries into the nature of choice, potentiality, and the relationship between mind and reality. Quantum jumping raises philosophical questions about the nature of choice, causality, and the linear progression of time. It invites contemplation of the implications of non-deterministic processes on concepts such as free will, determinism, and the nature of causation in a quantum-influenced framework. While speculative, the exploration of quantum jumping may inspire novel approaches in fields such as quantum computing, information theory, and experimental psychology. Potential applications of quantum principles in technological innovation and scientific inquiry may emerge from ongoing theoretical and experimental investigations. Quantum jumping prompts interdisciplinary exploration at the nexus of physics, psychology, and metaphysics. It invites researchers to consider potential parallels between quantum phenomena and observed human behaviors, cognitive processes, and the nature of consciousness, fostering collaborations that transcend traditional disciplinary boundaries. Ultimately, the implications of quantum jumping transcend disciplinary boundaries, sparking inquiries into the nature of reality, consciousness, and the potential interplay between quantum phenomena and observed phenomena in the macroscopic world. This concept serves as a springboard for interdisciplinary exploration, philosophical contemplation, and the exploration of the fundamental nature of existence,